Orange Story comes on Friday next week. Do not miss the Orange Story. If you like the Halloween story, Orange Story better.
Orange Story.
Tell you. I will say that there was a law or two that were broken during the Orange Story.
Wait, Lawrence.
More laws.
Oh my God! What is the Halloween story
The
about?
graveyard.
The Native American graveyard.
Yep.
And the woman.
It wasn't me. It was Jason that slipped through the grave and TJ who knocked over the gravestone. So
Oh my gosh.
I was running. Cop showed up.
And it was on like a Native American
A
grave.
Native American grave, like it's not just some old white person's grave, you know. It's the
That's like
spiritual
secret land right
vigilance.
there.
Yeah, it was bad. It was bad. Not proud of it, but all right. Can we move on? We're good? Happy? Content? So no test this week, which I know most of you are pretty upset about. Actually got an email that somebody kicked a puppy because we didn't have any
Oh, God.
quiz this week. All right. So my friends, I am on page 31 of the notes. Page 31 of the notes. Weigh in the statistical evidence into one mean Z test. Okay. All right. So I'll do what I do. We always calculate p-value by assuming the null hypothesis as our starting point. As such, we build a model, sampling distribution, assume that a true null hypothesis. Then we test our sample to see how likely or unlikely our sample would be if the null were true. So again, our null is what we test. Okay? And that's important to know because the null, there could be evidence, and they're using terms that are kind of loose terms. The null is the not of what we think might be happening. Okay? So, they have an example here. They claim that Denver Water has been $55 a month for many years. It would be wonderful if we kept a $55 a month, but we didn't. And then they said there was a standard deviation. So this is the mean, a standard deviation of 8. Okay? So we could easily associate this with a normal curve. So that's basically what this is saying, that this is what they have observed over a lengthy amount of time. But now these people who came in to save water, so they sent us all the new shower heads to put on that you have to take, a shower that's 5 times the length to clean yourself. But hey, we're saving water. They have that to reduce the bill. The plan will collect a random sample of 100 current bills. And to see if we have reduced the water bill. The hypothesis would be as follows. So our alternative is our mean is equal to $55, and our alternative is that our mean is less than $55. Okay? So the average bill is still 55. The average bill is now lower, so it's one tail because we're looking at lower. So we create a null hypothesis sampling distribution, use a sample of 100, the mean and standard error of the mean and standard error of this distribution would be 55 and 80. Now, so this is the new information, and they're saying the standard error, which now is the standard deviation, but the reason you have a standard error that is different is because they've already used this equation to get the standard error. Okay? So what they did is they said, oh, we knew we had 8, we did 100, so we do the square root, and that gives us our 0.80. Okay, that's where that comes from. Okay, but they had already given that to us. So if we build our information, it's going to look a little different. Actually, I'm going to go back and just use this. So we know this, but then this is changing to 0.08 plus 0.08, and this is changing to adding another 0.08. This is subtracting 0.08. This is subtracting 0.08. So basically what that's doing on the normal curve is 8 versus 0.08. If you go 0.08, you're really squeezing it in closer, right? If the null hypothesis is true, we'd expect to see the result of relatively close to the mean, $55, because you're only talking about 8 cents. Okay? If we see an unlikely result, it calls our null hypothesis into question. Again, this is our null. Okay? So it calls that into question. As such, we use the results for our sample to weigh the evidence against the null. Simply put, the farther our sample is from the mean, the stronger the evidence against the null. So let's say our random sample produces a water bill. So we have the sample, we produce this as a water bill. Okay? So 5450 is like here, right? So let's just put a little thought into it. If I subtract 0.08 from 55, I get to 5492. Okay? If I subtract another, so what's happening with this is this information, if I had done my normal curve using this information, this actually falls like here. It's way down to the left. So this to the left, even though 5450 is pretty close to 55, being that we have our original sample of stuff, we had a standard deviation of 0.08. We had 8 cents. That was different. Okay? Is it really enough to allow us to wiggle or not? Well, it says the result is fairly close to the mean, but the sample simply could be a product of dumb luck. The sample doesn't prove or provide much evidence against the null. Then let's say our random sample was $45.75. Okay. 45.75 is way down far to the left on our normal curve using the 8 cents with our standard errors in there. Okay. This is way below the entire normal curve. It's very hard to believe that the null could possibly be true. Okay. Null being it's equal to 55. So, how could it be? How could we believe the null could possibly be true when the chance of producing this result is very low? Now, is there a chance it could happen? Yes. Is it possible you have somebody who is, takes one shower a week and they actually, just do a sponge bath? They could have a very low water bill. It's very possible you found that one person. But as far as a sample of 100, it wouldn't go. All right, so that's kind of the ins and outs of that. So you have to remember, standard error becomes your new standard deviation. Our original standard deviation, we were deviating from the mean of $8, and then we went to 8 cents because of our standard error. Okay? Assume that, and the next thing on page 32 says, let's say we have this political candidate running for office, wants to have more than 50% support. We conduct a random sample of 400 likely voters to see whether this candidate has that level of support. Okay, and this, unfortunately, we are coming up on the midterm elections, so we should start seeing partial truths in advertising that comes our way. Okay, so the hypothesis would be as follows. So our null is P is equal to the 50%, or 0.50, excuse me, and our alternative is greater than 50%. So one tail, because we're looking to the right. It might seem that it's strange to select 50% as the null, but this value is our default baseline value. Another acceptable option is to state whether the hypothesis is, so we could have this as well. Okay, so we could go one of either way. And why does that one have an equal or is not, just so we're including? We create the null hypothesis by sampling a mean of 0.50 and a standard error of 0.025. So if we draw our normal curve with that, put in our standard error, we're safe now. Plus 0.025 plus another 0.025 or minus 0.025. And then notice I'm just going out 2 standard errors or 2 standard deviations. Okay, so that's our sketch of what it would look like. Okay, what are we testing? We're testing this, or we're looking at this. Does this indeed take place this way? We don't know. If our random sample produces 52.7%, so if we showed 52.7%, 52.7%, this is not very strong evidence against our null. Okay? Now 52% is pretty close to 50%. Agree? So it's kind of hard to sit there and say, it's not that far away. It's only 2.7 away. But if we look at our standard error, if I start coming out this way, if I go out this way, I get to 52.5. So I have to go out a second standard deviation. So now I'm out here, way out here for this 52.7. So it might have been that we got lucky with that sample. It might be true, and that's the key with stats is you having a might. There's definitely arguments you can make, and I think I could easily, and I think you all could easily argue, 50% versus 52.7. It's so close, but it really becomes important to realize that standard error is the standard deviation you want to start using, and so we're looking at information out to the right. If our random sample produced 50.7, this is not very strong evidence against the null because we said the null is 50%. This result is too close. Strong evidence against the null. The result is too close to the mean. They are saying, but it's still far from the mean. Our sample produces a sample of 57.2%. Is this very far from the mean? They're both far from the mean. Okay, if I go out to the 57.2%, I'm out here on my normal curve. I'm pretty far to the right. I'm like 12 standard deviations out. You're talking about a tiny population. Okay, so in the next few sections, we will finally convert a p-value, finally convert into a p-value, and we will be able to reject or fail to reject the null hypothesis based on the p-value. So just know that standard error, you have 2 different equations that we use. So this is population standard deviation. This is the number of people, number of sample. But we also have this equation too. So we've used these equations, both of these, and this was x bar. And standard error of p. So that was what if you had percents. Okay, and p is the percent. 1 minus p is the just subtracting it, and then n is still the sample. So notice where the square root goes. Square root's over everything here. Square root's only on the bottom here. So those are a few things that you will definitely come across into our information, and I know that we have a test plan for next week. It won't be Friday. So I think we have enough information to look at 6-6. Talk to me.
One of the questions, number 5, asks for a calculator command. How do we find that out? Like, how do we know what to put in? It says use normal CDF, but how do we know what to put in as the normal CDF?
Let's take a look. Let's go here. Pull this up. We haven't used normal CDF for like 3 weeks, so.
Yeah.
And you can tell it's been a while because the computer's taking a long time to clear. So bars, normal CDF. So our lower user graphing calculator show the percentage of normal distribution to the left. Which one was it? 4?
5.
4 and 5?
Oh, sorry, number 5.
5. So to the left, so our lower would be 0, because that's way left.
Yeah. And then our higher would be 747.
Yeah, that's a big
Or
airplane.
upper, I mean.
And then I think we would be,
We have the mean in the,
we do have that?
well, I think so. It says in the problem above, a certain fast food cheeseburger has 750 calories. So
Okay.
would that be the?
Yep. That would be our mean.
Okay. And then the standard error that I got was 2.78.
2.78.
Mhm.
So you got that based on,
Well,
where did the 2.78 come from?
so we don't have a standard deviation
Right?
in the problem at all. So then how do we find the standard error?
Ooh. So does that go back to percent? 1 minus percent. I think what we could do with that is you would do 747 divided by 750, and that's going to give you a certain decimal.
Okay, but so number 2 at the top, that asks us to calculate the mean of the standard error.
That's where you're going.
Right, so then why would we use 747?
Because that was what our
But that wasn't mentioned in the original problem.
I'm pretty sure it's got to be this because
We don't have any
we don't
other
have
information.
that. Calculate the mean and standard error. According to the label in fast food, 750, but we actual calorie count is higher. Plan to randomly purchase 36. I think you're right. I don't have.
We don't have.
Calculate the mean and standard area of the null hypothesized sampling distribution. I think we are missing that. So let's just make this up. Let's say that our standard deviation, and we'll just add this to it. Let's call it 2.
Okay,
Sound good?
yeah.
All right,
We're
so
just missing the information
yeah.
for this one.
Yeah, add this as that information because I think I agree with you. It is missing.
Okay, so then we would just do the standard error 2 over
Yeah.
the
So
square root of 750.
yep, that's exactly right. 2 over root 750.
Okay.
Yep. Let's do it with that. That'll work. That's a good idea. Thanks for looking at that. Yeah, I apologize that it wasn't there. You are absolutely right. It is not there. Yep, you're absolutely right. So cool. Good deal. All right, I'm playing along.